Good morning, ninth graders. I wanted to go through a little review today on ionic bonding and the Happy Atoms worksheet that we had worked on a few days before we left. And I had a question about metals and how they don't tend to get to the next noble gas. Remember, we talked about noble gases trying to get to that lucky number 8. Basically, we need to get to 8 electrons in our shells or in our rings for us to be a stable atom. That is what we call the octet rule. However, this question was, well, why doesn't these certain metals here, like magnesium, lithium, aluminum, why don't they want to get to the next noble gas? And the very reason why is because of, don't forget what they do, right? Metals tend to lose electrons. The nonmetals tend to gain those electrons. And so don't forget about that question. If we lose electrons, we are losing what type of charge? We should be losing a negative charge, right? And if we are gaining electrons, we're gaining a negative charge as well. And so with nonmetals, these always tend to gain electrons to get to the next noble gas. But for certain metals, these metals over here, all these metals here, these metals on this group here, what they tend to do is they lose those electrons to get to the last noble gas behind it. So if I was at, in this case, sodium, what I'd be doing is I'd be losing this 1 electron on sodium, right? This has 1 valence electron because it is in group 1A. It's going to lose that 1 valence electron, and it's going to go down to the last noble gas. And if I am a nonmetal like phosphorus, I have to gain electrons. I have to gain what? 1, 2, 3 electrons to get to that noble gas, which is going to be argon. Now let's do an example here. Let's complete some more. I was going to go through some more every day that we had been going. However, with this e-learning distance learning schedule now, we have to work through it through videos, basically. And let's talk about aluminum. So, element symbol for aluminum. What is that going to look like? It's going to look very simple. It's going to look like Al. Now, if I can draw Al. Using a new trackpad here, and so it's going to be pretty hard to work with. Al. There we go. Now, number of valence electrons, well, we look in the grouping, right? We're in group 3. Now, it says 13 up here, but don't forget that Roman numeral 3 here, right? So, we're in grouping 3. So here should be 3. Now, the electron dot diagram, what is that going to look like? Well, don't forget, we still have that symbol, Al, and we have to add 3 electrons, right? But we have to add them on opposite sides. 1, 2, 3. Now, it wants to be like which noble gas? Now, here is that hard part. It wants to be like which noble gas? Well, we got to think about it for just a second here. We have 3 valence electrons right here. Is it better to lose 3 valence electrons, lose 1 here, 1 there, 1 there, or is it easier to gain 5? Think about it, which one's easier, losing 3 or gaining 5? I think losing 3 is going to be easier in this case, because what's going to happen is if we're losing 3 electrons, it's going to be less energy than it would to gain 5 more electrons. And so we're going to lose electrons, right? Metals, that's why metals in this case lose electrons. And so we are going to be like which noble gas? In this case, we're not going to get to argon because we have to gain 5 to get to argon. We're going to lose 3. We're going to lose 1 here, 1 electron, 1 electron here, 1 electron here, and we're going to find ourselves at the previous noble gas, neon. Previous noble gas, neon. So it wants to be like which noble gas? Neon. And that's true for every metal. If we want to go, in this case, if we're working with any other metal, we want to get to the previous noble gas. So if I'm working with iron, I'm going to lose a specific number of electrons, and I'm going to arrive at the previous noble gas, which is argon. If I am at osmium down here, right, I'm going to lose some electrons, and I'm going to arrive at the previous noble gas, which is xenon. So it's that process. We have to lose electrons, go to the previous noble gas for metals. And for nonmetals, we gain electrons, go to the next noble gas. So in that case, what's going to happen? It needs to gain or lose how many electrons? Well, I've said it a lot of times here. If we want to get to the last noble gas, we got to lose its electron on aluminum and the two before it, right? So we got to lose a total of 3. Again, we can always look at the group number, right? If we're in group 3, we're going to lose as much electrons as that group number for that metal. So we're going to lose 3. So it's going to lose 3. Now the ion formed, again, it's that same what's it's going to look like for that symbol, Al. However, again, if we're losing a negative charge, we are going to become more positive as a result. 3, right? Losing 3 electrons makes me 3 plus in this case. What's my ion name? Well, again, don't forget that when we're working with cations, with metals, we're going to keep the name, right? It's going to be aluminum. Aluminum. So that's going to be for metals. For metals, don't forget about that. We always go to the previous noble gas. And I have a nice little graphic about this, about how things kind of bond. And so we can see a few things about this graphic here. And so we see that sodium, to begin with, has 1 electron on its outer shell. And that should fit with what we have, right? Sodium has 1 valence electron. It should have 1 electron on its outer shell. And the other atom was going to be chlorine, right? It has 7 valence electrons on its outer shell. Again, it's in group 7, so it has 7 valence electrons. Now, what's going to happen for this type of bonding to occur is that 1 electron on sodium is going to transfer its electron to chlorine. And so in this case, what's going to happen again is that if we lose that electron, we see sodium becomes positive. And if chlorine gains that electron, it becomes negative. And look at what we have here. Once we lose that electron on the outer ring, we have 2, 4, 6, 8 electrons on that previous ring. Don't forget that every atom wants to get to 8 electrons. And they can do that by gaining or losing electrons. And so if sodium loses its outer valence electron, it's going to arrive at a position where it has 8 electrons already. And if chlorine gains that electron, it arrives at a position where we have 8 electrons as a result. And so that's what we're kind of dealing with here. We want to arrive at a particular 8 electron scenario where we can find ourselves at a noble gas. And if I count up these electrons here, 2, 4, 6, 8, 9, 10, well, 10 electrons, that's going to be neon, right? It has atomic number 10, which means it has 10 protons, 10 electrons. And so what happened here was that, again, with sodium losing that electron, it arrives at a noble gas configuration at 10. And chlorine has 17 already, 17 electrons. But if it gained that 1 more, it becomes 18. And at 18, we find ourselves at argon. And so again, chlorine wants to gain 1 to get to argon. Sodium wants to lose 1 to get to neon. Hopefully that kind of cleared things up. I will be doing another video on a few more examples. And if you have any questions, please let me know. Again, this was about ionic and covalent properties. But again, always ask me questions. I do like hearing questions. Alrighty, I'll see you next time.